Assalamualaikum and greetings. In this video, we'll be talking about chapter 6, which is the alkyl and aryl halides compound. So, the alkyl halides compound can be represented by R, which referring to the carbon-carbon chain. And then it must attach to the halogen compound. While for aryl is a benzene compound which attach to the halogen. Okay, the halogen is from group 7, which possess of fluorine, chlorine, bromine, iodine, and also acetylene. But normally for our discussion, we're going to limit our discussion for chlorine, bromine, and sometimes iodine, for examples. Here are the outlines for this topic. Of course, we're going to have nomenclature on how to propose the common and also the IUPAC name for alkyl halides. For method preparation of alkyl for the method of preparation of alkyl halide, it already been discussed in previous chapter. So for this chapter, it only highlighted 2, although for previous topic we have more than that. The first one is preparation from alkene compound. Okay, the other one is from alkene compound. Both of the method has already been discussed in previous chapter. We're going to go through that later on. In the reaction of alkyl halide, okay, although it is listed 4 here, in this slide, there will be no reduction of alkyl halide and also hydrolysis of greenite reagent, because both of this has been clearly discussed during chapter 1 alkene in the subtopic of the preparation. Okay, you might want to refer to the slides. Okay, the highlight of our discussion will be focusing on these two, which is nucleophilic substitution and also elimination. And for your information, the alkene, the elimination reaction, also is part of the discussion that we have done during the alkene chapter during the preparation reaction. And finally, you can read about the uses in the slides at the end of this chapter. Okay, let's go for the IUPAC name, a little bit discussion on this. So as you can see here, if you just refer to the IUPAC system, you might notice that most of the time, the halogen will be treated as the substituent. Okay, for instance, for the first structure, CH3CH2F, okay, the longest chain was 2, and then there's only one fluorine. Therefore, the name of the parent will become ethane, and then the fluorine will become fluoro. For the next example, the longest chain is 4, and the chlorine is attached to the first carbon, and it will be called as chloro. Same goes with the third example, and also for the fourth example, all of them will be treated as a substituent. This is logic because, okay, we already knew about the priority of naming an organic compound. The highest compound will have the highest priority to become the parent chain will be carboxylic acid, okay, followed by carboxylic acid derivative, and we have the acyl halide, we have the anhydride, we have the ester, also we have the amide, followed by aldehyde, ketone, alcohol, alkyne, alkene, alkane, and the rest will have lower priority compared to alkene, including the halogen compound. Again, I would like to state that the halogen compound is the fluorine, the chlorine, the bromine, iodine, and also acetylene. Okay, therefore, most of the time, if you want to apply the alkyl halide compound, okay, it will be treated as only substituent. However, the other system that we can use is also the common name, which we prioritize the halogen compound. So instead of making the ethane as the parent chain, we're going to treat the ethane as a substituent. So it will become ethyl, and then the fluoro becoming the parent, so it become fluoride. The chloro will become chloride. The bromo will become bromide, and finally the iodo will become iodide. Again, I would like to remind that for our discussion, we are prioritizing the IUPAC system. Okay, however, the knowledge for knowing the common system is also essential. Let's move on to the preparation. So, as I mentioned earlier, the preparation of alkyl halide, okay, dated back to the previous chapter. For instance, first method, it can be halogenation of alkane, where we convert the alkene compound into Rx by performing the halogenation reaction, and we also discuss about the free radical substitution. Okay, you might want to refer back to this topic later on. You can refer to the previous notes. And the second method is by using the hydrohalogenation reaction of alkene compound, which also already been discussed during chapter 3, which is the alkene compound. For this hydrohalogenation, okay, it must follow the Markovnikov or the anti-Markovnikov, depending on the reagent that we are using. Please take note that if we are using peroxide such as H2O2, okay, it will prefer the anti-Markovnikov. So basically, you can see in the general equation, we have an alkene, and then when we react it with unsymmetrical reagent, what's going to happen is the double bond will break, and then we're going to add both of H and X, so it will become an Rx compound. So these are the two methods to prepare the alkyl halide for this chapter. However, don't forget there is also preparation of alkyl halide from alkyne. This is the slide taken from chapter 2. So as you can see here, this is the reaction, one of the reaction which we're going to discuss, which is the elimination reaction. Okay, for instance, if we have an alkyl halide, which is the Rx, we react it with strong base, so it's going to perform the elimination reaction. So the elimination reaction will produce an alkene compound together with the side product. Okay, this is the general reaction that we have discussed in chapter 2. In this chapter, we're going to go into detail whether the elimination proceeds whether in E2 or E1. Alright, E2 is referring to the elimination bimolecular, while E1 is referring to elimination unimolecular. Before we proceed with the question of substitution and elimination, this is a brief explanation regarding on how to differentiate the substitution and elimination reaction. Okay, in general, if we have an Rx, okay, so let's say one should contain hydrogen and the other carbon should attach to hydrogen, doesn't matter any hydrogen. So there will be two main possibilities for the reaction to happen. First one is we're going to replace the X with a nucleophile. So let's say if we have a nucleophile here, what's going to have to happen to the structure is the X will be eliminated, and then we're going to attach it to the new nucleophile. Of course, there is other factors which are going to influence this reaction. Okay, so for this reaction, this will be called as substitution, or it can abbreviate as SN. Another option is if the X and also the H will be eliminated, and it's going to form C double bond C, meaning that it's going to produce an alkene. This reaction will proceed in the elimination mechanism, or it can abbreviate it as E. Alright, so in order to explain this further, let's take a look at one question. Okay, this question was taken from November 2005, and hopefully it can really explain on how we can differentiate both of the substitution and elimination reaction. Okay, if you read the questionnaire, identify the type of mechanism SN1, SN2, E1 or E2 for the following alkyl halide. Okay, let's ignore this first. Okay, let's ignore the classification first. Now let's take a look whether the reaction proceeds as elimination or substitution. For A, you can see that we have CH3, CH2, CH2, CH2Cl, and then we're going to add OH negative. And what's going to happen to the product is, we notice that the Cl is being replaced by OH, and then it's being omitted out from the carbon-carbon chain. So basically, this is clearly, if we refer back to our earlier diagram, you can see that the X, which is in this case the Cl, has been replaced by the nucleophile. So the nucleophile in this case is the OH negative. Please take note that every nucleophile has the negative charge. So clearly this is a substitution reaction. For the second example, here we have the Br and then we have the H2O. What's going to happen is H2O can also be written as HOH. What happens is the Br is being replaced by the OH, so the OH attached to the carbon-carbon chain, while the H will combine with the Br. Okay, this is a typo there. Okay, suppose the product will be HBr. This is the similar reaction which happened on A. Therefore, this can also be considered as substitution. Okay, for the C, we have one chlorohexane which reacted with ethanol in the strong base. So as you can see here, there is formation of double bond. If we refer back to our earlier diagram, we notice that any elimination reaction will produce a double bond. Compared to the substitution, we are replacing the nucleophile. So any product which resulted into formation of double bond will be considered as elimination. And finally, for the last example, we have CH3, CH3, we have the chlorine and the second carbon, and then immediately we notice that one of the product is double bond, therefore we can assume that there is elimination, while the other one, the chlorine, is being replaced from OCH3 from the alcohol just now, so this is a product of substitution. So guys, technically, from this example, hopefully we can differentiate what is the substitution and the elimination reaction. Next step is we're going to determine whether it is bimolecular or monomolecular for each reaction. Okay, so for this example, it is easy for us to determine whether substitution or elimination because we already knew the product. The issue will arise when we are dealing with this one. As you can see here, we are given the starting material and also the reactant. Okay, however, there is no product. Therefore, the challenges here is how we determine whether it undergo which mechanism. That's why, to understand this, we need to understand that we need to compare 5 factors. The first one will be the type of alkyl halide that we are using. Second one, it will be the strength of the nucleophile or base. Okay, there will be 2 possibilities, whether it is strong or weak. The third one will be the concentration of nucleophile and base. Number 4 is the solvent, and finally you will need to consider the temperature of the reaction. In order to really determine which reaction proceed in which mechanism, we'll be focusing on these 2. Okay, there are 3 of them. Okay, it can be classified into primary, secondary, and tertiary. For instance, for primary, we have CX, the carbon attached to the X, and then we are looking on how many carbon attached to the CX group. So carbon having 4 bonds. If the carbon attached to none or only 1 carbon to the structure, like this will be considered as primary. The second one, if we have CX and the carbon having 4 bonds, including the X, if it attached to 2 carbon, this will be considered as the secondary. And finally, if we have a CX and then all of them attached to a carbon, meaning that this will be a tertiary. Okay, this is a very crucial factor because we have the effect of the steric hindrance. So technically, by looking at the type of the alkyl halide, we can predict whether it's going to undergo the SN1, SN2, E2 or E1. For instance, the primary will always prefer the SN2 reaction. The substitution reaction will take place. For the tertiary, it will prefer the elimination or perhaps SN1 and also E1 reaction. It's a little bit tricky to deal with the secondary because for the secondary, it has this option, which is it can also happen SN2, E2, SN1 or E1. Okay, from earlier, again, by using the type of alkyl halide, you can predict which reaction will occur for the substitution or elimination. The second factor will be the strength of the nucleophile that we are using or the base that we are using. So technically, if for SN2, it will prefer a strong nucleophile. For E2, it will prefer strong base. But for both SN1 and E1, doesn't matter. It can also proceed by using either weak nucleophile or base. So, in order to make it simple, you should know that example of weak nucleophile and base is only 2. The first one will be water, and the other one will be alcohol. So if you take a look, there is the presence of this weak nucleophile or base. So always consider the reaction will occur in SN1 and also E1. Okay, what about strong? Okay, we go for the strong base first. Strong base such as potassium hydroxide, sodium hydroxide, and any of the strong base that you are familiar with. Okay, sometimes the base can also act as the nucleophile. Okay, for example of strong nucleophile, we can also say it is KOH, NOH, it can also be NaCN, and other than that, species with negative charge such as OH negative, and of course we are going to have OCH3 negative. Okay, these are example of a very strong nucleophile. Again, I will have stated that by referring by these first two factors, okay, we can determine easily whether the reaction occurs in substitution or elimination reaction. Let's refer back to our earlier example. As we can see here, we already knew that this is SN reaction. For B is also a substitution reaction. For C it is a elimination reaction, and finally for D it is comprises of the substitution reaction and also the elimination reaction. Alright, our challenges here is whether we're going to determine whether it proceeds under bimolecular or unimolecular mechanism. So let's take into account the two factors that we have discussed earlier. First and foremost, let's determine the type of alkyl halide that we are using. Okay, for the first question, as you can see here, okay, I would like to zoom in a little bit. Okay, if we draw back the structure, it will be looking like this. The C attached to the Cl, and then you have H, and then it attached to, CH2, CH3, which means that this is a primary alkyl halide. If we refer back to our previous notes, we can see that if we are using primary, it will prefer the SN2 reaction. Alright, however, let's confirm it with the nucleophile that we are using. As you can see here, we are dealing with OH negative. Again, if we refer to the type of nucleophile, we notice that strong nucleophile, one example is OH negative. Okay, you can check the list of the nucleophile in the slides. So this is clearly that by using primary alkyl halide together with the strong nucleophile, we can assume that this will be SN2 reaction. Right, there is no SN1 reaction. Okay, for the second one, the type of alkyl halide that we are using, okay, I would like to zoom in first. It will be looking like this. We have 1, 2, 3 attached to Br, and then there is a double bond, methyl group attached to the first carbon. So if we refer to the structure, okay, it seems that this will be a secondary. Why? Because this is the CX, and then it attached to 2 carbon. Okay, therefore this will be a secondary. Okay, let's take a look at the comparison. Okay, you have the CX and it attached to 2 carbon. This will be a secondary. The problem with the secondary alkyl halide is it can either be SN2, E2, SN1, and also E1. That's why we need to check further with the type of the nucleophile or base that we're using. So in this case, we are using water. If we check back the type of nucleophile, you can see that water belongs to the weak nucleophile or base, meaning that it will prefer either SN1 and E1 reaction. Therefore, if we check back the structure, we knew that this is an SN reaction, a substitution reaction. However, it cannot be SN2 because we are using weak nucleophile. Therefore, the only possibilities will be SN1. Alright, for the next example, C. Okay, here are the CX and then it attached to 2 carbon, therefore this is a secondary. Just like in B, for secondary, it can undergo any mechanism if we are using a secondary alkyl halide. It can be SN2, SN1, E2 or E1. So let's check whether we are using strong base or weak base. In this case, it clearly stated that we are using a strong base such as potassium hydroxide or sodium hydroxide. Okay, because we already know it's an elimination based on the formation of the double bond, we're going to assume that this is E2 clearly from the usage of the strong base for the reaction. Okay, we already determined for A, B and C. Okay, what about the last one? Again, SN1 substitution can be either SN2 or SN1. The elimination can also be E2 or E1. So let's take a look at the alkyl halide first. The alkyl halide again is a tricky one because it is a CX attached to 2 carbon, which is secondary. Again, secondary, the SN2 or SN1 and also E2 or E1 can occur when we are using a secondary. That's why we need to check with the next factor, which is the nucleophile or base that we are using. So we have CH3OH, which is a type of alcohol. Therefore, we know that alcohol is being considered as weak. That's why the only possible mechanism that can undergo will be SN1 and also E1. We can eliminate both SN2 and E2 because for both mechanisms it requires a strong nucleophile or base. So there you have it. For A is SN2, B is SN1, C is E1, while D is both SN1 and also E1. Let's take a look at the next question that I discussed earlier. This is question 9. Predict the mechanism SN1, SN2, E1 or E2. So let's apply the knowledge that we have learned before. Whenever we came across this type of question, always consider that we need to identify the type of alkyl halide first and also the type of nucleophile and base that we're using. For the first question, you can see here that we are using 1-chloropropane. If we draw back the structure, it will be looking like this. Okay, this is the CX here, and the CX only attached to 1 carbon. Therefore, this is primary. Again, primary carbon, primary alkyl halide will prefer the SN2 reaction. However, let's check with the nucleophile that we are using. So in this case, we are using NaCN. Alright, we're going to consider this is a strong one because Na belongs to the first group, which is consists of the metal group. So by having this attached to Cn, then this will be a strong nucleophile. The combination of primary together with the strong nucleophile clearly they support a SN2 reaction. So for the SN2 reaction, as you can see here, okay, it must substitute the Cl into the nucleophile. In this case, for NaCN, we know that Na, sodium, normally is positive, while Cn is negatively charged. Therefore, what's going to happen is the Cl will be replaced with Cn, and the side product will be NaCl. Okay, this is a combination of the Na with the Cl just now. But okay, yeah, the important thing is you already determine the mechanism because this is the requested by the questions. For the second one, okay, for the second one, okay, we have the CX here, which the halogen is Br, which attached to 3 carbon, therefore this is a tertiary. Okay, for this example, we can immediately eliminate SN2 because SN2 is preferring primary alkyl halide. So the option that we left is either E2, SN1 or E1. Let's take a look at the next factor, which is the nucleophile. In this case, we are using water, which is weak. Therefore, we're going to cancel out E2 because E2 requires strong base. Okay, just like the SN2 require strong nucleophile. Therefore, the answer left with us is SN1 and also E1. So what's going to happen is there will be two products. Okay, we can draw back the water molecule as HOH. So for the product of substitution, we're going to substitute the Br into the nucleophile. So between the H and the OH, the Br will be replaced by H to give you the compound of this. Okay, and then for the elimination, we need to have the formation of a double bond. Therefore, it will look like this. Most importantly, we know that this reaction representing both SN1 and also E1 because we are using water which act as a weak nucleophile and also weak base. The third one will be a secondary alkyl halide because the CX attached to 2 carbon, this will be secondary, and secondary is a little bit tricky because it can undergo any mechanism, whether SN1 or E1 or SN2 with E2. That's why we need to refer to the nucleophile, which is sodium hydroxide, which can be considered strong. Okay, because it has metal group attached to it, and of course OH negative, which representing the strong nucleophile. Therefore, clearly we can eliminate SN1 and also E1 because we are using the strong nucleophile or base. So there will be two options. The first one, the Cl will be replaced with OH from the sodium hydroxide, and the other one will be the formation of double bond, okay, to represent the E2 product, while the substitution will representing the SN2 product. Okay, last but not least, okay, we have the final question. Okay, identify the alkyl halide first. Okay, it only attached to 1 carbon, therefore this will be a primary. Immediately we can consider this will be a SN2 reaction because SN2 is the only mechanism which prefer the primary alkyl halide. Then we have our negatively charged nucleophile. So we know that for SN2, okay, it will replace the Cl with the nucleophile which is O CH2 CH3. For this question, it's not important for you to draw the end product. However, you need to state clearly which mechanism that occurs for this reaction. So we have for A is SN2, for B SN1 and E1, for C is SN2 and E2, and finally for D is SN2. That's all part of the introduction to the alkyl halide topics. Okay, there will be another follow-up video to explain some of the questions related to this chapter. If you have any question, please leave a comment below or ask directly in the Telegram group. Okay, see you guys in another video. Goodbye.